My name is Tristan Roddis. I work for a company called Cogapp, and I want to present a project that we've done jointly with the Science Museum and working with Daniel Evans, their head of web there, who unfortunately couldn't make it but helped me to prepare this presentation. What I'd like to do is talk a bit about this project, which we ended up using linked data. It's a project kind of in progress at the moment. You'll see we haven't got any firm conclusions yet, but hopefully to tell you about some of the things that we learned along the way. And to start with, in a way, what the context for this project was the fact that the Science Museum, in common with, I would imagine, many large institutions that have been going for a long time, has got lots of disparate data silos within their organisations. There's lots of pockets of content, but they aren't really joined up. And for example, here's one microsite that was developed about 5, maybe more years ago, talking about the biologist Alexander Fleming. But then they've got another site which is to do with their image library online, and that again has lots of narrative text also to do with Alexander Fleming. Same time, they've got a collections database, and there are items related to that person, but it's not connected. And finally, another microsite, this time managed within their content management system, and again, object information that's created especially for the web, but isn't connected in any direct way to the object information in their collections management system. So to actually list the number of different sources we're talking about, they've got a collections management system, they've got a digital asset management system, they've recently purchased an archives management system as well, and they're busy populating that with the result of a digitization project for the archives of Sir Charles Babbage. And they've got a web content management system, and also then lots of legacy content, which in their case takes the form of XML or even HTML files, which again they would like to have accessible and crucially related to the other piece of content. So here's a diagram. This is what it looks like at the beginning of the project. So what's the big idea? Essentially, it's to take information out of all of those different silos and to link it all together, and to use linked data as the one format that will describe all of these different systems. Now, just to point out that what we're talking about here is not a consolidation project. We're not taking information and putting it all into one new format. What we're doing is setting up systems that can work on a scheduled basis to extract the relevant information and then populate one central system that can store a representation of all of these things. So the underlying content systems continue to exist and have their own outputs, often to the web in one way, shape or form. But we want to create an intermediate system that allows us to navigate and explore that content in a much richer way. So this is the big idea. Grab everything from all of the different data sources and put it into linked data format into a triple store. So a quick digression about what linked data is and why we thought it was a suitable answer to the problem. Essentially, data can be described in lots of different ways. Roughly, there's the idea of relational data, which you can see or almost tabular data, and this is things like Excel spreadsheets or relational databases where you've got rows and columns of information and then joins between different tables of information. There's also a hierarchical description, and again, the most popular method for that is XML, where everything can be described as a nested series of information fragments. And then finally, there's graph data, and this is what linked data is. It's a way of looking at your information, but instead of as a hierarchy or instead of as tables, as seeing everything as interconnected nodes on a graph. So how does this happen? It happens by means of something called an RDF triple. RDF is resource description format. And a triple it's a bit like a sentence that human beings would speak. It starts with a subject, then a verb or predicate, and then an object. So this triple here, drawn out at the top there, the subject is me, an identifier that represents me, Tristan. The predicate, the verb, says I have a first name, and the result, the object of that sentence is the literal string Tristan. So expressed in the actual language, RDF it's shown at the bottom, and there's these angle brackets there. But essentially, the thing to note there is that each of these parts of the triple, apart from the literal string Tristan, are expressed as URIs. And these URIs look very familiar to things that you all know, which are the URLs used in your web browser. And they exist for the same reason, that they can be guaranteed to be unique. So in this case, the subject here for Tristan, it's under a domain that I control, or at least my company does. And so in that way, I can guarantee that no one else will have control over that identifier. The one in the middle, this is something FOF, and this is where it's reusing a common vocabulary that somebody else has established and decided that a way to describe the first name of something can be used via this identifier. And essentially what you do is you grab these triples, they stand alone as just two items with a line between them. But where it gets interesting is where you start adding more. So if I start making more assertions, again with the same identifier, I don't know if I can get a pointer on this, I can't, I'm going to wave. So the same identifier could also say that, okay, I am a male person, I have a home page, but then it gets more interesting when you start to link it to other nodes that themselves have things, so that I'm a member of the node called Cogapp, which can be described, it's got a name, and it's a type, it's group, and so forth. And so you can keep on building this out until you form effectively a gigantic graph of interlinked data. And so essentially this is the key idea of linked data, also known as the semantic web, which again popularized by Sir Tim Berners-Lee. And this is what it adds up to. So to create a linked data system, what you need is obviously these RDF triples themselves, so you need a system to be able to generate those. You then need a triple store, which is analogous to a database server. It's somewhere to put these things and to store and index them. And then something called a Sparkle endpoint. Sparkle is like SQL is to relational data, a language for querying and interrogating relational information. Sparkle is a language for interrogating graph data. And so on top of the triple store, you put a Sparkle endpoint, which will talk a standard protocol, and you can use this to submit your queries and effectively interrogate your data. And if you want to get really fancy, you can also add something called an inferencing engine, which effectively allows you to add rules to your data. So on top of the raw data that's stored within the system, you might have a rule that would say if something has a predicate of either has father or has mother, also given the predicate has parent. And so you could then do one query that would say, find me all the people who are parents of somebody, without having the more specific ones. And so you can build up arbitrarily complicated rules as inferences, and again, it gives you more power over how your data can be represented and modeled. Why is linked data interesting? Well, essentially, it gives you an extremely flexible way to store the information. So unlike relational data, where you have to know exactly what your tables look like in advance, and if you want to add a new thing, you've got to effectively alter the schema of the table, add a new column, and so forth. With linked data, the triples are the definition of that data. So you can just add those to the triple store, and your data model can grow. It can store ragged data. You don't have to know in advance exactly which of these, all of the rest of the graph to make it useful. It's also very flexible in terms of querying. There's unlike XML, where there's an inherent hierarchy in information, and it will make it very hard or easy depending on how that hierarchy has been set up. With graph data, there is no inherent hierarchy, and so you can query things from either end of the graph and get the information you want. It also helps in terms of evolution of data, in that as long as you can match up the identifiers that you use, then you can evolve your data model continuously, and it makes it very easy to change the data that's in there, or to layer or merge it with other data sources, so long as you can agree on the identifiers. And it's a standard format. Again, that Sparkle, for example, unlike SQL, or where databases all have different, you need to install different drivers and so on to use them, Sparkle is an open standard. It works over the web, and effectively you can do things like federated searches across one data store, joining it with another data store, so long as they both have a Sparkle endpoint. And then finally, there's the opportunity to link your data to the wider web of data, also the semantic web. And so if you use standard ontologies, they're called ways of describing your information, then your data can interact and be related to and linked to information in the wider web of data. That's what it looks like, that web of data. Apologies, you won't be able to read anything there, but the address of this slide will be in my notes. Essentially, what you've got in the middle there is DBpedia, which is the linked data representation of all of the content from Wikipedia, and then all sorts of other knowledge domains that are interlinked and linked to each other. So how did we do it? Effectively, it depended. It depended on the source system. So, for example, with the collections management system, MIMSI and iBase, we have an in-house tool called Cogapp that we've used a lot for extracting collections information and generally representing that as other relational databases. But for this project, we taught it a new trick and got it to output RDF triples for all of the information that it had extracted. So we would have scheduled tasks that will run and pull out information for that. For AdLib, they kindly provide, which is the archive management system, they provide an API which allows us to do RESTful queries. So we wrote some Python scripts that query the API, use RDF-lib to generate triple representations. And then the other two are in progress. With Sitecore, we're looking at adding a workflow hook so that when people publish articles there, it will, every time a publish event happens, it will fire off to extract the data we want, transform it to triples and push it to the triple store. And for these legacy XML documents, it would be things like a one-off import. We don't actually need to have the scheduled updates going there. What did we get out of it? We got something that looked a bit like this. This is the data model as it stands at the moment. I'll be coming back to that and zooming in a bit because I realise it's very hard to read. We also got a Sparkle endpoint, and we can now do arbitrary queries over this consolidated data. So here is the Sparkle query for find me all the people who are called Babbage, and it turns out that in the Science Museum know about 2 different people with the surname Babbage. And kind of if you then went and interrogated those further, you could track down the connections. And in fact, here's a little graph I generated of the connections from all the different data we know about Charles Babbage within the system. However, it didn't always go smoothly, and there are a few things that we learned along the way. So one of the first things that we needed to consider is that of identifiers, because linked data from the outset starts off with the idea that you will, or at least could, take part in this global web of data. The idea is that your identifiers have to be unique, and they also have to be stable. They have to be as permanent as you can make them, because they may well end up being used by external systems. And so in that case, sort of at the bottom there's an example identifier that we end up using, an example of one of these URIs. And here we take the domain name of the organization. And then the second part, there's a subtlety, something called 303 redirects. And there's a subtlety in the semantic web community to do with the difference between something that identifies something and then the representation of that something. And what this takes form is that in terms of IDs that get passed around, in general, you'll use part of it, the ID section here, but when a machine comes to retrieve that information, then it will get redirected using the 303 redirect protocol to a document that actually describes that object. And then the final subtlety was to do with opaque versus human readable, that depending on who you talk to, there's a lot to be said for having a human readable URI that may go /people/Charles/-Babbage 1806 or something like that. But on further talking to people who'd done linked data projects in the past, in particular the British Library, they recommended that actually it's much better to go with an opaque ID scheme, because things change. Even things where you might think, if I concatenate someone's name and their date of death, that's never going to change. Things do happen. People do change their names. What are you going to do then? And so we deliberately went with an opaque identifier, and we kind of prefixed it, in this case, as sort of SMXG, just an arbitrary acronym for the source of that information, because if we're taking identifiers out of MIMSI and these things are sequential, there may well be other sources of object information that also have sequential identifiers. So think of things like that. Here were two resources that were very helpful in working out a URI scheme for all the data. And then there's a larger question of how. There's so many things, there's so many ways of describing information. Dublin Core have an idea of how to do this. In fact, they have two ideas. There's friend of a friend, something very good for describing people and the relationships between them. SCOS is good for describing categorization formats, hierarchies and so forth. There's domain-specific models, in particular the CRM for describing cultural works. And then the Europeana have got their own and somewhat different view of how it is. And then schema.org, the new kid on the block for microdata, but again, widely supported. And so it goes. And so it's which of these should you hitch your wagon to? This is our big and unresolved problem. Essentially, what we came up with was this. And we followed a few design principles, and we kind of came to these after talking to other organisations, the British Library, the British Museum, the Archives Hub in England, who'd done similar projects. And there were a few guiding principles about here. The first one is we wanted to model our domain. We wanted to use words that kind of meant things to us. And so we've got objects. They're a museum. Who knew they have objects? We've got their agents, which is a slight abstraction. It represents both people and organisations. We've got assets that describe those objects or people. And then we've got concepts which categorise those things. So one is modelling the data that worked for us. And half of it was pragmatism, because it was the way it was easy to extract this way. Another part of it was just working with a thing that we would try to represent the information that they had in their institution. Another one was trying to minimize the number of different classes to try and keep this as simple as possible, because although as I said, linked data, you could put anything in there, it's not always wise to actually do that. And then the other thing was to try to reuse some of these more popular ontologies, and finally to limit the amount of repetition. And so an example of this popular ontology, the friend of a friend, here when it comes to describing people and organisations, we try to use the standard ways of doing this, the name, the given name, the family name, and so on. Another thing, when it came to categorising the information, what we found is that using the SCOS ontology is actually a very simple but very powerful way to model almost any sort of categorization, be it hierarchical or sort of just multiple tags applied to things. And so here, with the SCOS broad and SCOS narrow representing going in and out of a hierarchy, we found we were able to model most of the ways that the information was categorized already, but sort of flatten it into one format and then crucially an interchangeable format. Another problem is that, linked data is still a new technology. It was proposed quite a while ago, but it's been quite slow in terms of real-world adoption, real-world uses. And what this means is that often there are subtle differences between the underlying systems. Although certain things like Sparkle and so on are standard, they're a fairly evolving standard. Not all vendors implement all of the Sparkle 1.1 spec, things like that. Inferencing schemes are certainly not standard across the different platforms. And then this idea of a small pool of knowledgeable people. If I want to find out information of how to do something with the Apache web server, there's an absolutely ton of information out there. If I want to find out how to use the Jenna triple store, it's a much, much smaller number of people who know how to use that and who've provided that information online. And then a sort of more subtle point is that it requires a mindset change. It means looking at your data in a very different way. Again, I can find loads of people who will help me normalize my database schema, but comparatively few who will give good advice about how to model the information and use it effectively. And then I think the final point is that linked data is no magic bullet. Although you're moving towards a more flexible and useful data format, you still have to deal with fundamental problems of the underlying data. And examples of the sort of things that you'll have to do is filtering tasks. It's certainly the case that not every object that is held in a collections management system is necessarily ready for public consumption online, and so there needs to be this filtering both at the sort of item level and also the field level, so that you're not exposing necessarily all of the curators' notes about things that they don't want to make public. There's a reconciliation task. As you join up these different systems, you need to make very sure that the identifiers actually match up, and also that we made the conscious decision to not have any orphaned content. So again, although you could put in all sorts of triples that may be described as standalone images, we decided we didn't want any assets just floating about unconnected from the wider graph of data. So again, there was a reconciliation, a filtering task there to make sure that we're only adding the images that describe objects and people who are already existing in the triple store. And then there's just, this whole process, and in a way it's a very healthy exercise, is it shines a light on all of your data as it stands. And so if there are inconsistencies in the way that that information is stored, the way people are using different fields, all of that is exposed in detail when you start trying to mesh it up with other systems. And another thing is that there's, the softer side of data, things like copyright. Again, it's one thing to kind of have a web page, but it's another thing to say, okay, we want to take the information that's on that web page and publish it as under a CC0 license, because again, half of the problem is to get everything available. So where to go next? What we'd like to do is there's plenty of things we can do with the data, and we can also look at the existing sources and how to improve those. Also, how we can go about linking this to the wider web of data. So again, a reconciliation thing that would maybe link up our places to the GeoNames database, link up our people to the records on Wikipedia. And then publishing opportunities. Again, what we'd like to do is make this data available. So one thing would be a Sparkle endpoint. Another thing would be to give an API to the data. So again, Sparkle is the most flexible, but it's not necessarily the most widely spoken, especially by developers. And so giving just a RESTful interface that gives you structured XML content is a very good way to push your data to the outside world. And then, of course, a website, a human-readable view of all this information. The other thing would be to pull in information from elsewhere, and it would be things like taking user-generated content and actually linking that up and exposing that in linked data format, and also external data. So, for example, if we can link up, we can tag our data with common identifiers, a same as assertion to say I am the same Charles Babbage as Wikipedia knows about, I could then go and pull in the brief bio from Wikipedia and merge that with our own information. And this is what kind of the red line show there is future directions, things that we want to explore and be able to do with this as we go forward. So that's it. Thank you very much. So, Rich, are we going to do questions now?
Yeah,
or okay, great. So, yeah, so I've got time for questions if anybody has some.
So what does this data look like in your system? Like you go in and do Sparkle queries and you have your own interface to work with all this data right now?
Yeah, so the question was, what does this data look like? Essentially, yes, we have, we're using the Apache Jenna triple store, and that comes with a Sparkle endpoint called Fuzeki. And effectively, it's through that we can query the data. And so there's a web-based interface. You can type in so the screenshot I showed you there was a web-based interface for running Sparkle queries. You can also use, obviously, code to talk to it, or kind of other standalone systems. So there's sort of RDF querier, Air app, I think, that I use, and you can just type in the queries and it will run it in the background and so forth.
So is that something you're using, or are the curators using it, or who's using this data?
At the moment, nobody. I mean, this is, we're in the process. We've got to the point where we consolidate everything, and we're trying to deal with these sort of inconsistencies issues. And then what we want to do, we've really kind of reached that turning point of kind of, okay, now we've got the information, what are we going to do with it? And that's a sort of ongoing process. We're sort of working with the Science Museum to work out what the best way to do it is do we go the pure data approach and say, here's a Sparkle endpoint, and the British Museum, for example, have done that. You can access all of their collections in linked data format. Or do we go let's put a website on top of this and almost hide the linked data entirely as an implementation detail? So there's several different approaches we could take. Yes?
You mentioned that you were pulling out RDF triples of like collection data as one example from a system. Does that actually create more reference points within works of art, as an example, or are you still using like the same set of data, it's just tagged differently for another purpose?
Yeah. So the question was, do we create new connections, or are they the existing ones? The answer is kind of within any given system, they are only the existing ones, but where the new connections get made is where the different systems are joining up. So when I was talking about kind of their DAM and their collections management system, their archive management system, is when those three come together that suddenly you can say, okay, there are archives about this person, and there are images about this person, there are images about the objects connected to this person, and so on. And it's taken as a whole, you are generating new connection. Yes?
So you said one of the possible outcomes of having that federated search on top of it would be to build a web interface so that people could search across your collections at one time. Is that so? How do you optimize the search engine there to get to the record level item? Is that possible?
So I think there's two approaches there. I mean, one is the purely federated search, and what you could do is you can expose one Sparkle endpoint that effectively then talks to two different repositories in the back, and so you could allow people to run arbitrary queries that would make a join across your data and that available on DBpedia, for example, and that would be the most flexible way to do that. But again, if you're exposing a Sparkle endpoint, that you're deliberately not optimizing anything, because you're just saying, okay, you can run any query you like. In practice, in code, what you would have to do is make sure that any queries that get auto-generated are not going to effectively mushroom and give you so much data that it would be impossible to handle, it would time out. The other thing in terms of efficiency is that what you can do is, as well as federating those searches, you can also do queries in advance to these external sources like DBpedia that would effectively say, get me all the people with the following identifiers, and you can import the triples directly into your own store so that there you effectively know you've got one store of information that you are querying, instead of having to wait for a sort of unknown network latency as it goes off to another endpoint that is controlled by somebody else.
I guess what I mean also is, let's say somebody, that's on your site though, you build that interface for it. What if someone goes into, Google and they go to Google Images, or they go from another search engine point, can it locate, like if you were to go into Google Images, is it possible to get a Google image to come up as a search result in that set from your repository?
Only if you've effectively done that work to take the information out of the repository and put it into a web page, to put it into a web format that Google is able to index. Yeah, okay, thank you.
See how this works. This is what was glitching out on me last time. Oh yeah, that's okay. You want to switch me? Or just go down, straight down.
Hi, I'm Charlie Moad. I'm the acting CIO at the Indianapolis Museum of Art and also the director of the IMA lab. And this is Gray Bowman, application developer at the IMA as well. And really today what we want to do is just talk about, we've been using Amazon Web Services for hosting our websites for the last 4.5 years now. So we thought at MCN this year we would just take a look back at that data and try to summarize and get a feel for where it worked, where maybe it didn't work, and give some lessons learned, especially out of a major crash we had at one point. And then on top of that, we're going to be releasing all our billing and usage information, and we have a little info viz we worked up that we're going to show today, and then we'll give the link to that so you have that for reference. That way you have a good tangible reference for what it costs to use these services to do real usage. So first, looking back, before, sorry, this screen's going funny. Okay, before we actually switched to the cloud, there we go, we had a very traditional hosting setup where we had a dedicated server at a facility that was hosted offsite. It was maintained by them. We saw a lot of downtime from that. It was actually very expensive, around $500 a month. We had very limited resources that we were allowed to use. And on top of all that, we had no control of the software. I mean, this is probably a common thing that a lot of you have seen, especially in the Midwest. 5 years ago, we didn't have very good bandwidth, so hosting in-house just was not an option. So especially with the onset of Art Babel, which is a collaborative art video site, we realized we needed a better solution. So this was probably a year or two after Amazon's web services came out. So we decided to move all our public-facing websites into the cloud, and specifically to Amazon, in order to have a cost-effective way to deliver video at a high rate of speed. So currently we host our main IMA website, blog, everything you would see public facing on the IMA side, plus Art Babel video. We have all our collection images in the cloud. We transcode all Art Babel video in the cloud. We store it there and we stream it, all using Amazon services. So that gives you kind of a scope of everything that we're doing on Amazon's resources. So here's just a quick look at the big numbers. So this is from April 2008 through September of 2012. EC2 is Elastic Compute Cloud. That is essentially their virtual machines in the cloud that you have full control of. So what we've seen is we had an overall usage time of about 9 years across all the machines at a cost of about a little under $15,000. That again included transcoding all the Art Babel video, plus running servers full-time to host those websites, 2 different servers. S3 is their simple storage service. So this is where you can store files cheaply and scale to as big as you can imagine. In the last month, we saw we had a little bit over a terabyte of usage. I think the actual month cost was maybe in the $130 or $150 range. But over the lifetime of using and storing files on S3, we've obviously grown to a terabyte. We've seen that cost under $4,000 in that time. CloudFront came along about a year after we came out with Art Babel. So originally we actually ran additional video streaming servers in the cloud to host our videos, and then Amazon released the ability to turn one of your S3 buckets, they're called, so a folder in S3, into a video streaming solution that you only paid for what you used, which was amazing and great. And it uses Adobe's media server on the back end. And I think we're suspecting a license to Adobe Media Server might cost more than we paid for all that time of streaming video out of Art Babel. So I summed it up. Yeah, we're looking at about 10 terabytes streamed in that time, and just a little over $1,000, which is pretty amazing. So not all the numbers are reflected there. We'll get to those. But that grand total across all services for all that time, $22,780. So really impressive if you priced out some servers and that type of storage attached to them. Amazon's come a long way, especially in their monitoring tools and their online resources. I think from a software perspective, I'm always amazed how we can prepare a machine in the cloud and just throw it around from one region to another, or move IPs, just pointing and clicking in this web interface. It's really nice if you can stage a website and work on one server, and whenever it's ready to go live, you can take your old server, just take that IP address, click it over, and it's an immediate change. You don't have to work with DNS propagation and things like that. It's just been really powerful for maintaining web upgrades and such. So some of the big advantages I'll just cover real quick. I mean, obviously scalability. You can scale beyond your institution immensely, as much as you can imagine. You're paying like a utility. So the great analogy here is just like you would pay for your electricity at your institution as you use it, that's how you're paying for these computing resources, which is just really a great model, especially for institutions that see huge spikes in usage. I know in Indianapolis, we have the Indianapolis Motor Speedway, and I think they easily see 60 to 70% of their traffic in a year over about a 1-month period. So this pay-as-you-go model just makes perfect sense for places like that. And I'm sure we have some institutions through here that see similar spikes around certain events. Obviously, you're not maintaining any hardware whatsoever. I mean, that's a huge advantage. You don't have to worry about failures. Well, we'll get to that. You might have to worry about failures, but you're not the one actually swapping the hard drives or worrying about that. I think in the entire time we've been running there, we got one email one time where they gave us like a 3-week lead time saying that they were going to do maintenance on our server, and we had to actually move our instance to another server. But beyond that, we've never actually had to move our running virtual machine to another server in that time. And then uptime has really been phenomenal, even though we did have one major outage. Just all in all, I think I still, whenever I compare it internally and versus what we had before, I think it's been just amazingly solid. The major disadvantages, just obviously slower access. It's not on site. Again, I mentioned, at least where we're located, our pipe to the internet is not huge, and so trying to put a digital asset management in the cloud, or digital asset management system in the cloud is just not practical to be able to pull that type of data fast. As a backup, I think it's a great solution, but if you really need quick access to these resources, you need something that's on site. Another thing that you would probably want to avoid putting in the cloud are machines that talk to your internal machines very frequently, because you are charged for that transfer in and out of Amazon services. So if you're shooting files or running sync processes all day long between machines that talk internally, that might not be a good match for you. Obviously, bandwidth, again, it'll compete with your current internet. So if you're putting heavy resources out there, that's something to keep in mind, that it might affect the performance of your local network at your institution. Some cloud services will have portability issues, and even for S3 or EC2, if you write code to move files between those, I mean, that's always something to consider, is you're writing services and processes specific to their infrastructure. So especially when Google has their app engine, that's something that you have to write it all through software, and so you have real portability issues there. Amazon's come a little further along on portability. I think we might be talking later about, they have a VMware solution. So if you run VMware at your institution, they actually give you the ability to throw instances up to the cloud and pull them back locally on demand, which is really amazing. The other thing that I call it a disadvantage just because it's tough is the fact that you need to integrate with your existing archival backup systems. And again, if you're trying to pull a lot of data back to put on your tape backup system, again, you have to worry about all those transfer costs. And I mean, backing up is still 100% your responsibility when you're using these services. So I will hand it over to Graham.
So now that Charlie's built it up for you a little bit, let me tear it down for you. I'm not sure how many of you are familiar with the Terminator movies, but April 11th, 2011 was the day that Skynet became self-aware and started eradicating humans. So on that same day, it just so happens that Amazon had a major outage. Amazon has a storage system called EBS, or Elastic Block Store. And basically this is a block level storage system that you can assign to your EC2 instances. And they also give you convenient ways to take snapshots of these EBS volumes and to back them up and persist them in S3. So it's very important that you take these periodic snapshots. We had, on this day when our EBS volumes failed, we had both ArtBabel and our main website, imamuseum.org, on EBS volumes. And we never did get ArtBabel back. We had to restore that more or less from scratch. We did the same thing for our main website. It did eventually come back, but I think it was 2 days, 2 days later, so it was non-acceptable amount of time, so we ended up having to restore that as well. So cross-region redundancy. This is something that's more of an advanced topic, but you'll see big players using this. Amazon has multiple availability regions, and they're positioned throughout the U.S., and I believe they have some European ones too. But you can think of them, they're geographically isolated from each other, but a lot of the services that Amazon provides are also isolated to these availability regions. So you'll see that for us, we operate out of US East 1, and all of our stuff is there. And you could implement some kind of redundancy across regions, like Netflix, for example. They have this whole system set up where if US East 1 were to go down, their systems in the other availability regions would take over and continue to provide movies. So that's something to consider. Again, that's an advanced topic, but if you have a service or something that you just cannot handle downtime with, that might be something that you need to look into. As Charlie was saying, you also want to integrate this with your in-house backup solutions. For us, that means using rsync. We have a local machine that we use to host internal websites at the IMA. And on that machine, we also do nightly rsync backups to it from our EC2 instances. And then our in-house backup solution backs up that machine. So we always have a constant copy of everything that we have out there locally in our organization. You want to make this part of your disaster recovery plan. Just because these instances are out there in the cloud, that doesn't mean that you shouldn't have a plan for what to do when things go bad. Case in point. And AWS does provide support. Amazon will sell you support for these instances, although based on what you're doing, it can be very expensive. And they have multiple tiers of support. So if you pay a little, maybe you get forms and emails, and if you pay a lot, maybe you get a dedicated person to talk to. But that is quite an expenditure. So some of the things that we've learned over the 4 years we've done this is not to make 3-year commitments. When you purchase an Amazon EC2 instance, you can purchase what's called a reserve instance, and you pay an initial amount of money so that you get a lower hourly rate. And what we found was the Amazon will reduce the prices of the hourly price of these instances over time. And what we found was if we commit to that instance at that price for 3 years, by the time that 3 years is up, Amazon will have reduced the cost of that instance enough so that we're not really saving any money anymore. And so what we tend to go with 1 year reservations. Again, I already spoke about integrating it with your backup solutions, very important. You want to make frequent backups. And this is all your responsibility. Unless you subscribe to that support, Amazon won't really help you out. They have a very basic level of support, and it's so basic as to almost not be support. So this is all, if you're going to use these services, it's all on you to make sure that you've got a copy of your data. So one of the newer Amazon services is Glacier. And this is, by its name, you can see it's supposed to be a slow-moving way of storing lots of data. And you can see based on, what was it, S3? Based on the difference between the S3 price, you can save quite a bit. For example, if we put our entire IMA DAM of 16 terabytes, it'll be $160 a month, which is quite a reasonable price. The problem with the Glacier service is that it's meant to put data in, but they give you a very small allowance for how much you can bring out. And I think it's like 5% of your entire allotment. Whatever you have in there, you can pull out 5% in a month. And then the overage charges, if you go over that 5%, can be quite hefty. I saw someone make a back of the napkin figure where they said if they had put 13 terabytes in and had pulled out 2 terabytes in a month, it would have cost them 22 grand or something. I can't really speak to the accuracy of that number, but it can be quite considerable. So yeah, Amazon will reduce the price of their instances over time, and they do that quite frequently. And they've also introduced some new instance types, and the new ones are a little bit different. The old instances would come with what they call ephemeral storage, which is storage that can disappear at any time if your instance goes down, so you really have to be careful about how you handle that. But these new instances come with the EBS volumes instead of the ephemeral storage. Also, Amazon provides a cost calculator, which show you here. So here's the cost calculator, and this can be helpful if you're doing kind of large-scale things. The problem is that it's very they want you to have a database server. They want you to have a number of web application servers. So it's very specific on what it'll help you calculate. And Amazon's known for having a very complicated pricing structure. So that's something to consider as well. So this is the link to the usage visualization, the info viz that I'm about to show. So if you want to copy that link, you can reference it later. This is a D3 based graph that we put together to show this information. Here you can see this is the total expenditure over time for our AWS usage, and you can see the total amount here is roughly 22 grand. But you can also break this down by individual services. Like for example, this is EC2, and you can see these large spikes are when we outlaid that cash to purchase the reserved instances. So if you remove that, you can see our average cost, hourly cost over time. And it's fairly consistent. You see it's grown because we've spun up more instances, but for the most part it stays rather static. Charlie talked about CloudFront as a way of distributing your content across the world, and also the data transfer. Now it's worth noting that the data transfer used to be wrapped up into the billing for EC2 until April of 2010. And then you can see the usage and cost for our S3 usage. And you can see this is more or less linear. It grows over time. You can see here on the 12th of February, or sorry, in January of 2012, they reduced the price for S3. And it's another example of how Amazon's always bringing down the prices. And for us, that did knock off a significant chunk of the cost. But over 7 months, our storage requirements grew to nullify that savings more or less. And if we look at these as a percentage of the total cost, you can see that for the most part, it's actually running the instances. CloudFront is only a small portion. The transfer is a small portion. And when you're looking at this information, you can highlight any of these graphs, and it'll bring up a tooltip to show you what each of these, a breakdown of what each of these costs are.
Yeah, and the last thing I'll point out is if you scroll down this page a little more, you'll see everything that actually comprises this graph, but most notably, this is the raw data in JSON format, and there's even code there on how to pull your own. So if you've been using Amazon, we have a repository where you could pull your own usage data and plug it into this. So
definitely. So yeah, this is all available. This, like I said, the link for this is IMATC. The /AWS usage, and all that data is out there. So feel free to download our data, look at our billing history.
Any questions?
Have you guys compared it all with Ocer?
No, I would say we're just strictly Linux lamp stacks, so hasn't really crossed our minds. Rich?
I was just
Other
wondering
Rich.
if you could speak a little bit about where the management of the instances and the storage lies in your organization. Do you have a traditional sysadmin who brings those up, or has this moved more into a sort of development DevOps area for maintaining these servers?
Yeah, I would say it's definitely a DevOps kind of thing. We do have, of course, in-house systems that are managed by our MIS department, and I think this is one of the advantages of AWS is that we can do this on our own without having to always ask MIS for something. And when it comes to especially like DNS changes or something that can be time sensitive, that's a great asset to have.
We do work with them, and we set up SNP notifications for outages and usage thresholds being passed. So there is some collaboration going on there too.
So are you guys going to stick with AWS given the disaster?
Oh, certainly. Well, there's a certain excuse to being on AWS when there's an outage, right? Because if Netflix is down, no one's really worried about if you're down, or at least you have a good excuse for it, right? You can be down, but you're in good company.
Yeah, it took down a big chunk of companies. All right.
You talked about the digital asset management system not making any sense to be in the cloud, and one of the questions I had is that, I don't know, when you were at the university, maybe you used Internet too.
Mm-hmm.
I know that Amazon ties into Internet too. Wouldn't that kind of, if you did have a high bandwidth connection to Amazon?
Yeah, do they bring in a new pricing structure for Internet to transfer? I'm seeing a no head shake. That's where the gotcha is. I mean,
Right. So yeah.
If anything, it's like getting LTE on your 200 megabyte limit iPhone. Just that larger bandwidth sometimes can bite you a lot quicker. All right, thank you.
Thanks.
That's good.
Sure, Mike.
Good afternoon, everyone, and welcome to the Sands of Change, Managing the Expanding Storage Universe. I'm Brian Dawson.
And I'm Graham Husk.
And we're with the Canada Science and Technology Museums Corporation.
We're a family of 3 museums. Under our roof are the Canada Agriculture Museum, the Canada Aviation and Space Museum, and the Canada Science and Technology Museum. We manage all the information technology services for these 3 museums, with most of our resources being located at the Canada and Science and Technology campus.
So for this afternoon, what we were hoping to do today was, first of all, just have a sort of broader look at the changing storage landscape that we're all dealing with in IT shops. We also wanted to look at some planning consideration with respect to storage networks, and we're going to give some examples from our experiences with NAS and SAN, and also an upcoming unified storage deployment. Really, these are sort of for the sake of getting a conversation started. We actually want to sort of get through some of the basics kind of quickly and actually open things up for discussion, because we'd actually like to get sort of alternate perspectives and maybe hear from some of you in terms of what you're doing in your organizations. So let's dive in and have a look at what's going on in the storage landscape. We'll start with in terms of something that, of course, everybody's experiencing in terms of the growth of data. This particular chart shows our growth pattern. So, conventional wisdom has data doubling roughly every 18 to 24 months, what have you. We've been tracking for a number of years both our structured and our unstructured data growth. The red line is the growth in our structured data, which is actually looks comparatively flat to the way unstructured data is growing. And it's not quite doubling every 2 years here. However, most of the growth, well, for some time it was images, and right now it's ramping up quite a bit in terms of video production work, and so there's a lot of video data that we're dealing with. And so there's actually a significant amount of data that's not managed in the formal systems that we're tracking here. We know that some of our designers and other people within the organization have hard drives directly attached to computers and so forth, and so there's actually tens of terabytes of data that's actually not tracked in our formal systems that we're aware of. So, in terms of dealing with this data, and to try to ensure that it doesn't just turn into digital landfill, systems are a key aspect for dealing with this. Now, this is more of a management diagram I'm showing here. This is an enterprise architecture diagram. I use this to try to explain to directors and VPs how IT systems support the core business of the organization. What I was just using this here is just to sort of talk about how the pivotal role of particularly on the more right hand side of the diagram, what we sometimes call our digital content core, the systems either that we have in place or that we're putting in place to deal with content, to deal with documents, to deal with rich media. So these systems are critical in terms of grappling with the data monster. So now, if we're going to talk about systems, probably is everybody who here is actually using virtualization? I suspect everybody. Yes. So, I mean, it's not surprising that the vast majority of the room is actually using server virtualization. And if you think of what's happened over the past few years, I mean, the data center has really been revolutionized, and it's actually changed quite a bit if you reflect on it. One thing that virtualization has done is that we've gone away from a server-centric view of the data center to an information-centric view of the data center. Rather than having, it's not that long ago when we were managing, it could be dozens of individual servers, and all the storage was attached to those servers, and your operations are focused on keeping, all of these servers up and running. Now, you're running virtual servers on multiple hosts. They can bounce around between the hosts depending on the availability of the different hosts. And the real critical core of the data center now is actually your storage network and your common storage pool. So it's actually really had significant impacts on the way that a data center is structured and the way that IT is organized and the types of work that we need to do. Another way to look at this as well, of course, is that virtualization is kind of a part of a continuum from going from a traditional server approach to virtualization. You can take that further to private cloud, or different public cloud approaches. And along this continuum, you actually get sort of similar benefits, but to different degrees along the way. I mean, virtualization, we're a mostly virtualized operation. We have some selected use of the cloud. And virtualization allows us to do things like buy as we go. In terms of the resources that servers are using, of course, you can use resources much more efficiently. You can be more responsive and scale within certain limits of your infrastructure. Obviously, things are far more elastic and on demand if you're looking at the cloud. But it's kind of a continuum. Like the benefits are in the same spectrum, if you will. Now, another factor that's really changing the data center is the rise of consumerization of IT, and seeing products that are sort of more geared for consumer use that are coming into the workplace and displacing or running in parallel with business products. The whole bring your own device phenomena, and also bring your own cloud phenomena. So we're seeing, it can be execs bringing in their iPads, which are an unsupported device for our IT operations, or people that start to use Dropbox or Google Docs or what have you, even though they're not platforms that we're actively supporting, we're not actually managing, and we don't actually yet have a policy in place. So then people are collaborating, corporate data is being stored on these platforms. The ease of use, the flexibility, the collaboration that these platforms opens up, I mean, it understandably creates new expectations, and there's new demands in IT. It's totally understandable why people want to bring these tools into the workplace. But until we get our policies in order and figure out a way of dealing with this, obviously there's issues that we've got to deal with in terms of management, security, support, and so on. So anyway, all these forces are actually having some significant impacts on IT departments, and IT departments are changing quite a bit. Storage networks now play a huge role in the data center. The new technology is actually changing people's jobs. With storage networks, the role of a storage manager and with virtualization and virtualization manager, these, if we roll it back 10 years ago, our job functions looked really quite different. And also the way that the critical role that storage is playing is also driving new requirements. If we think about the availability requirements and redundancy requirements in terms of how we organize and operate our data centers.
So let's start talking about some of the planning considerations. I'll just leave it over there. With these planning considerations, we've had to take into account a bunch of different factors. Obviously, upfront planning is going to be foremost and should be tackled with a real eye to making sure you understand the problem you're trying to solve. First of all, make sure you get accurate information about your data. Now, there's a number of different sources that you can use to help you understand your data and what you're looking at. First of all, we've used threat and risk assessments to help understand what uptime is required for the data. Data trend reports to help us understand the growth potential, as well as hardware purchases that may be required in the future. Now, with our new digital asset project, we're actually going out and we're polling users looking for local-only data, as well as any projects they might be working on that may actually cause a dump of a huge amount of data onto our storage infrastructure. Another consideration is your budget. We have done two things to actually help us with our budget. One of them is we phased the purchase of our SAN for our first virtualized environment. This phased purchase allowed us to get something for a not reasonable, but at least acceptable price, and it also allowed us to upgrade for more data space as required. The other thing that we did is with the digital asset project, we are looking at the sharing of the corporate budget for the project to allow us to buy a better suited piece of equipment for that necessity. Again, staff. These people are really important, and so to get ready for something entirely new and something that is so critical to the infrastructure, first of all, we used contractors to help fill in the information we didn't have, as well as bringing them on site and letting them do the work on site so we could actually glean information off them as they were working on the project. The other thing we did is we made sure that we sent people out to registered courses that we knew that would give them the information to handle most situations, even if we still had to go back to contractors for something later on. But don't do it just for your primary staff. Make sure that people that back you up, or back the positions up, I should say, also have the same training so that they can be as effective in the position if there's an absentee. And of course, as everyone knows, something's going to go wrong. So, first of all, make sure to add some sort of excess to both your project budget and your timetable to allow you to make sure that you don't run into problems that will cause your project to go very sour and can cause management to look at the project and wonder exactly whether you guys are doing what you should be doing towards the corporation. Also, please, if you can, we do suggest you set up some sort of test environment to ensure that as you're getting these products set up and tested, all of a sudden any problems that are there become exposed before it becomes a production problem. SAN versus NAS. As most of you are probably aware, they are not exclusive. But in the past, these products have been separate. With our new digital asset project, we're going to go for a unified storage system. Now this allows us to have a SAN that allows us to do all the stuff for our virtualized environment, but also a NAS so that we can have a perfectly redundant system providing SMB and NFS shares to the end users. As well, in consideration, you have to determine what sort of networking you'd like to use. The fiber channel has some very great pieces of it, but you have to understand that it's going to be a higher cost, and you also are going to have an entirely different skill set than you probably already have in your office environment or in your IT environment. But once you've got that tackled, fiber channel is much easier to actually get set up and to be able to use. As well, it tends to be more reliable than your standard networking equipment because it was designed to be that way. What did we do? We didn't go that way. We decided iSCSI would be better for us, partially because of budget considerations, as well as having a great in-house expertise with TCP/IP and standard Ethernet switching. So when designing stuff, you want to make sure that redundancy is extremely high on your list because failures will happen. Having no single point of failure is key to be able to do that. This is a diagram of our storage architecture based on the new unified storage system we will be getting. As you can see with all these little lines running around, the end data users end up having multiple paths for the NAS which go around the outside of the diagram. Further to that, the SAN also has multiple paths to multiple switches, which are then multiple paths again back to the virtual servers, or virtual hosts, I should say. As well, if you can replicate your data to a separate site, it's always preferential because you can actually lose a whole site at a time, and that can be very problematic for continuing business operations. What we'd like to do is take our science and technology campus, put the unified storage there, and move our old sandbox over to another area. Although it doesn't have as much storage capacity, we can make sure that we maintain the core systems that will run our environment. So on top of that, though, as you see in this diagram, we also have a NAS server sitting there. This is legacy, but it can be repurposed to allow us to have growth time available so that we don't have to buy everything up front for our unified storage. Also, as you see, there's a little backup device there, and it's tape. So, planning for backup. Most people that have had to deal with backups over a long period of time realize that the backup window has been one of the crucial problems with backing up large amounts of data. One of the ways you can work with this is make sure you're backing up only the volatile data and that you archive when required. One way also to shorten this is to back up directly from the SAN. The SAN to your backup device is going to be so much faster, and you can get full systems quickly, like full VMs, as opposed to just the data off those VMs, which makes it easier to restore and get back up and running if necessary. We use tape. Why do we use tape? First of all, we've never found that tape can't restore the information quick enough to meet our end users' requirements. Secondly, it is so easy to take a tape and send it, even with our security staff, up to another location. As long as you've got the proper container, you can give it to almost anyone as long as they put it where it's supposed to be in some sort of safe location. We also use LTO. LTO for us has been this marvelous piece of technology, and it's not finished growing. With that growth, we'll have more capacity and we'll have much more data speed. And as I like to say, the price is ridiculously low per gigabyte. Storage security is also important. Easiest thing to do is zone your iSCSI network or your, well, fiber channel is a little different. Zone it away from your user network. That way there's limited access. Also, your storage equipment access is extremely important, both physical as well as role-based admin. Make sure you know who's supposed to do what and who has access by what means. As well, stay on top of updates. It's both a functional problem as well as a security issue. Now, for management, what we found with our devices we bought so far is the basic console provided works. And it works well enough for us to actually pull a lot of information and be somewhat predictive. However, in our virtual environment, because things were starting to get complicated, we went for the SolarWinds console, and that's allowed us so much more flexibility as well as creating specific user-defined reports that help us get even more accurate data out. Monitoring is so important because it helps us plan new purchases as well as justifying these purchases to management, as well as fixing minor problems before you end up with outages and severe loss of data. These are real pictures of our data center. These are not advertisements. But the data center is a multidisciplined science. The data center has your informatics staff who know what they need to get the job done, but it also must involve your facilities or building people because they will also have to pour a lot of money into making sure that your server room supports all this infrastructure. Planning considerations here are also project management, planning for maintenance and support costs, whether the cloud will have a role, using different types of disks to actually reduce costs, UPS and generator use, as well as making sure that the right size for your environment, that you have just all the physical structure in your server room to do what you need to do, as well as a retirement path, because things only last so long and you can only be upgraded for so long. And if you can reuse your old equipment, that's really, really good, as long as you understand that that equipment will also have an end date itself. There is also the possibility of billing other customers who are storing data and really don't have an idea of how much it really costs.
So at this point, what we really wanted to do was open this up for some broader discussion. We've tried to illustrate how we've tackled some of these challenges, but we'd be curious to know what other people are doing. You know, how is your data changing, and how are you managing your storage? You know, how are you handling your backup? What role is the cloud playing in your organization? So we're free to take any questions, but also if you have a perspective that you'd like to share, please let us know.
I have a question.
Sure.
What kinds of data do you put on block iSCSI versus what kind of data do you put on NAS file?
Well, the NAS has been typically used for the simple purpose of allowing people to have some sort of a remote drive that is redundant as well as backed up. So we have used it also for what should be specific PC backups, but we've never put an automation software in to ensure that that happens. We just give them the space and allow them to use it.
But if we think about the new document management system, for example, so typically, for in terms of block, all the OS, like all the running virtual servers, for example, are
block storage. But
the document store for the document management system is file storage, right?
Yeah.
So it can still be a bit of a mix even for the same system.
But we are looking into ways from moving it from an SMB type store to actual block storage and having multiple access to the same block storage.
Stuff to share block storage, right?
I'm not entirely sure about this. I've got feelers out to different companies and different products, and with a bit more research I'll be able to figure out whether it's actually applicable or whether it's too risky.
It's tough to share blocks, right?
Yeah.
One server's assuming it has total control.
Yeah, but I have seen software out there to allow multiple control. I don't exactly know how it works yet.
It's usually failover, or it's a clustered OS or clustered.
Not one particular piece of software I'm investigating, but I don't want to go much farther into it until I can actually say with certainty whether it's something that would be worthwhile using.
So would you say that NAS would fit your unstructured data better, whereas the SAN would probably fit your structured data better?
Structured data and virtualization.
Well, mind you, if we think about our document management system, though, again, like that one, that's a case where the actual document store is on the is on it's on what's on NAS storage,
Yeah.
essentially, right? So the documents are in the document management system essentially become structured data, if you will. You could
Unstructured
argue the
source.
point.
Right.
Yeah. Anyway, depends on where we draw the line.
Can you say what unified storage product you mean?
No, but thanks for asking.
We have an RFP that's about to go on the street, so we're actually open-minded on that right now.
What do you guys use as your backup in your server monitoring?
Server monitoring is done very simply, and it is a little admin intensive. But since most of our servers are on a virtualization package, the SolarWinds helps to really keep track of that. It's our physical servers that we still have a few of them left hanging around that are more problematic.
Backup?
Well, and for backup, we're using the HP LTO small library type systems.
What software do you run with it?
We're using HP's Data Protector. A long time ago, I will admit, I did a check of different softwares, and what I found was that the best software was great, the worst software was good, and I was able to find a price point in between. The Data Protector just fit. And one of the things that I love about Data Protector is if your GUI doesn't work properly, you can actually go in and edit text files that will actually do, that are actually being represented by your GUI. So if a server can't be picked up, I can go in and actually put the MAC address of the server in and describe the server as far as operating system. All of a sudden, it appears as one of the servers in Data Protector. Actually, they're called clients in Data Protector, but I think you get the idea.
Can you say what your rough cost is per gigabyte on your tape backup?
Well, the tape backup does anywhere from 1.5 terabytes native. It's supposed to up to 3 terabytes compression, but with video and pictures, it never quite gets that far. The best we've had out of the tape is 2 terabytes on the tape. For $40, that's not so bad.
What are the costs of the drives, though?
Drives are in the $3,000 to $4,000 area, and the library we use is a 1-drive, 8-tape library, and it hovers in the $7,000 to $8,000 area. But if you think about it, it's almost an unlimited disk size because I can just keep on throwing tapes at it until it goes, no more. We have huge amounts of data off-site now, and every 6 months we have what's essentially considered an archive that remains off-site permanently. And every once in a while, though, we try to get to testing it just to make sure. But we're no different than other corporations in that we have run into a problem with the fact that software that runs old backup systems can no longer be supported under the modern operating systems, and so the data ends up effectively being lost.
These are for the very old.
The very old, like I don't know if anyone remembers the Mammoth tape drives, or the OnStream tape drives, or the DAT tape drives. We've got all that stuff, and we still have those tapes because we have to keep those tapes. But if somebody says, I need the data back, I'm going to go, well, how much are you willing to pay for it?
Yeah, in practice that doesn't happen. I mean, the core role of the backup system, the yearlies,
yeah.
we can go back to the yearlies that we need to access.
Yeah, and please correct me if I'm wrong, but my understanding is our organization really is only dealing with 7 years data retention.
Yeah, other than museum materials, yeah.
Yeah. So, and we're mostly doing just the business part of the thing. Of the thing. We're mostly doing business operations management. We actually have somewhat separate knowledge bases for both the exhibitions as well as we have other people that do some. Oh, in the design department, because they're all Macs, they essentially have their own network, which is also connected to our network, and with different software, and with the fact that new Macs are Active Directory ready, we are moving closer and closer. Oh yes.
Do you find that SolarWinds exposes all of the performance information about the SAN that you're able to track down bottlenecks?
Yes and no. Yes, SolarWinds has a much better reporting tool than the standard consoles. But what I find I'm doing now, just to make sure I really understand the problem, is I take the information from SolarWinds and then I compare it against the VMware console and start playing with what data is really coming out of what and what each data means. And I can create a much more complete picture using both of them than I could using either one of them. But SolarWinds is the better out of the two.
I would like to throw one thing out there, just maybe somebody in the room knows. I mean, the Glacier technology that they were discussing too, it seems to me that ideally with the way that our industry seems to be going is that everything is going to be cloud-based at some point or another. And Glacier does not charge you to put stuff up there. They only charge you when you take it out. So assuming you are archiving stuff and it is something you're probably never going to touch again, it makes a lot more sense to pay for a dedicated internet line of whatever bandwidth you can hold just for your backup system, throw it up there, and never have to deal with tape, replacing your tapes, your monthly, whatever, your hardware maintenance of it, any of those kind of things that are associated with it in the long term. I mean, that seems to me like where the future will go.
I agree totally. But at this point in time, I have certain trepidations about moving entirely to the cloud, especially with something as crucial as restoring business operations.
Well, and I agree, because I mean, I know one big caveat to that too is that Glacier has a 2-hour turnaround time just to get the data. You can't get it immediately. It's like you put in the request, 2 hours later, it'll be available for you to download, and then you have to download it. But I'm just saying, it seems like...
And what I can tell you is, most of the time that we have to restore for business operations, it's based on a 1 or 2 day loss.
There's one other little caveat that we've got to be consider. We're a federal government entity in Canada, and there's some restrictions in terms of management of personal information that we have to watch for. So there's a bit of debate and I would say some controversy over it. But some people are of the opinion that we're not supposed to be storing personal information of Canadians, like membership information or things like that on servers that are outside of Canada, or particularly servers that are inside the United States because of the provisions of the U.S. Patriot Act. So that actually throws a particular wrinkle for us in terms of which services we might consider to use. That's not everyone's situation, obviously, but it's something that we have to consider as a Canadian federal organization.
What's the biggest problem in your solution?
The biggest problem in our solution?
When you have installed, what are you hitting as?
Well, right now, our NASs aren't entirely redundant. So if we can move a NAS head onto a SAN system that has entire redundancy right from the controller board up through the networking, that would be a much better solution, especially if we have to temporarily store stuff like the document manager repository on a NAS.
Yeah, but it never gave you any real problems, right?
Sorry, that's such a broad question. I'm sorry, I'm really not sure how I can navigate that.
Let me make it more specific. Did you ever have a breakdown?
Oh, we've had breakdowns. We have had breakdowns, but for the most part, they've been entirely manageable.
Yeah, the worst breakdown we actually had in our data center would have been in a case where a module in our core switch in our data center failed in a way that was just unpredictable. It was it was very difficult to diagnose exactly what was going on, and part of our storage network was going through the switch. So
actually, if I may correct you, the storage network itself wasn't going through the switch. The storage network was entirely safe. It was using other switches, but none of our virtualization would work anymore. And the problem was the switch was going up and down like a yo-yo. So people would be working away, and all of a sudden their services would disappear. They'd look around for a while. Oh, they were back. Okay, I'll continue to work. And the situation just kept on getting worse and worse. And it actually started the night before it became the real problem, but it was so solid at that time with just wee little intermittents that it wasn't even noticed until the next day. As it turns out, it was something so ridiculous that one slot and the one card caused a problem. But if you got a new card and put it in another slot, it worked fine.
This would have impacted us no matter what solution we were using, or cloud or not, because it was basically bringing down our entire network. So it's kind of a bit of a side problem in terms of the worst problem we had to diagnose, and also even though the switch was failing, it never raised any error flags. So it just it thought the switch thought it was running cleanly, but the controller was this one controller module was failing.
I want to tell you, you know how we figured out that there was a problem? Brian was on the phone to the tech. It was probably about 10 o'clock at night, and things were just going really wonky. We didn't know what to do. So I went into the server room, and I was just looking at the switch going, and all of a sudden all the lights went down. I went, what? And then flash, 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 down again, flash, 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 and then I realized it was in a reboot cycle. What? So I stood there and went, okay, that's unusual. Within 30 seconds, the whole system repeated itself. We were in a dead-end loop that we just couldn't get out of, and the best diagnostic tool was a pair of eyes.
You found a cricket in a relay, right?
No, Hydro One was charging us too much money. Anyway, no, the thing is, it was a very freaky set of circumstances. But Brian and I spent close to a 30-hour day that day solving the issue. We got it back up and running, and within one day, the whole thing really came crashing down the afternoon of the day previous. By the next morning, we were up and running consistently, and we had all the services back online. Of course, 30 hours worth of work didn't exactly go down well, and it actually took us out for about, I guess, almost 2.5 days because of how tired we were after that, and having to get back into the normal work and get our brains back to where we could actually see life, the universe, and everything.
And personal tool, yes.
Oh, yes, please.
Are you considering off-site replication?
Yes, as a matter of fact, if, right there, the two-way data replication between the two sandboxes.
So this is a target diagram. This isn't actually what we have in place right now, but with the new system, we'll be putting in place an off-site replication. And we're going to use our, we have 3 campuses, so we're going to use our Aviation Museum campus as our off-site campus for replication.
We've survived so far without it, but we don't like it.
Yeah, one other.
Oh, sorry, please. Oh, go ahead, please.
How far apart is these sites?
Well, about 10 kilometers, about 7 miles.
Oh.
6 and a bit miles. And although that's not true disaster recovery in a sense, it's definitely business continuity.
What kind of bandwidth do you have between those sites?
100 meg?
No, it's a 1 gig.
1 gig.
Between, we have a transparent LAN service with the local provider, so we're on the same fiber loop. So we've got a 1 gig connection between the two. It's effectively actually a subnet over the transparent LAN service.
Do you guys use Active Directory?
We do, yeah.
Do you, with the NAS stuff, have you noticed any issues getting permissions to sync with the Windows stuff? Because NAS usually has its own Linux-based on.
Oh, because the NASs we've been using in the past are Windows NASs, the Windows Storage Server family, okay. There's been no problem. But yeah, we want to test that before we actually bring our unified storage in play.
Yeah, it's been kind of a nightmare on a couple of
Well, yeah, and but I mean, it will be one of the conditions of the RFP that, you know, Active Directory and the NAS are working on the same, in the same playing field.
If I can ask, was it a case where something was supposed to work on spec, but you actually found the actual integration was something else?
We were replacing a faulty NAS,
yeah.
And apparently when you do it, it has its own user IDs. It basically takes the user Active Directory and assigns its own number to it. And if you don't export that list, when you reassociate it and re-put in all the things, it basically assigns random permissions to all the different folders. So now you have users.
Well, thank you very much. We will keep an eye out for that.
Okay.
The model, kind of stepping up a level above kind of exactly what you guys do, but the model for the 3 organizations participating and paying into this, how does that work?
Well, actually, we're one common crown corporation, so we actually operate. All 3 museums are one entity. Now, something the various. There are 4 Crown corporations that operate national museums in the Ottawa region, and I think that we're going to actually see some increased cooperation already. There's some joint procurement going on. So we operate very independently, but there's different forces that are bringing the organizations together. In terms of the timeline for our project right now, other museums have moved forward with their storage, their latest storage projects. So we're not at a synced procurement cycle right now, but thinking through some sort of common sort of server storage environment might even be an opportunity for a future rev down the road.
And what's the transparent LAN service? Is that like dark fiber, or is it something else?
It's we have a VLAN over a local. Well, actually, it used to be a local Utelco, which was bought by Rogers, but
it's lit fiber, isn't it?
It's lit fiber, yeah.
So they're actually managing the connection for you, even though it's...
They manage the connection.
Yeah.
We also get some dark fiber for them for some of our interbuilding links at different campuses, but that's actually lit fiber that they manage.
Yeah, and so we at least trust them to manage the redundancy between campuses.
Right.
Yeah. We actually lucked out because some of our campuses are actually in fairly remote sections of the city. One on the experimental farm, another which is like this old airport down by the river, and there's nothing else around it. But we were actually able to we were close enough to be able to trench to their fiber from all 3 sites.
Yes.
With this, you mentioned are you going to be charging for storage for these individual programs, and do you have management support for that effort?
We don't have management support for any of this. But
we've talked about it, and I think as we roll out our dam and look at how we're providing storage space, it's going to come as part of the rollout of our dam project. But we actually don't have the buy-in for it at the moment, to be totally honest.
Okay, it's 5 o'clock, so I'll make sure everybody can go to that one.
Yep. All right, thanks everyone.
Thank you.